Welcoming you all to this amazing session. We have a panel of speakers from Algorand. Okay, so till Aya joins, let me give an overview of how the session will be. So, Adamas University is finally having its first of its kind blockchain club, like we already have the GDS club and
Club,
others.
like your GDS
This Algorand
members,
blockchain club will be
this
another
current
club
blockchain
in
company
our campus.
up
And ABC
and ABC
Algorand
Algorand
student-driven
driven
um, approach where we
approach
nurture
in
students who are interested in learning
who are
about
interested
blockchain
in blockchain
and maybe
and
learn more
maybe
about how
learn more about how
blockchain is applicable to different
blockchain is applicable
industries.
to different industries.
Maybe you are interested in
Maybe
development, they can learn
develop
how full stack
and learn
development
how to start develop
works, how to
works,
integrate
how to
blockchain
integrate
with the existing
blockchain with
project to
existing
make
project,
it more
make
robust and secure.
robust and secure.
So over to you, Saira.
Over to you, Sarah.
Thank you, Sandeep. I think I'm audible.
Yeah.
Yeah.
Thank you. Good morning, everyone. It's been quite nice to see all of you here. Welcome to the session of Algorand Club here at Adamas University. After so many challenges, we are here. I'm thrilled to see this huge number of interested people from our university in blockchain technology. I'd like to, for those who may be new to Algorand and AlgoBharat, let's have some brief overview. Algorand is high performance blockchain platform that aims to create a borderless economy. And AlgoBharat is Algorand for Bharat. AlgoBharat is now building trusted infrastructures for India for the borderless economy. And its mission is to use blockchain technology to help India's general population access markets and capital more democratically. This team aims to do this by developing sustainable Web3 technologies and expanding blockchain technology more. Our purpose of Algorand Club is to provide a platform for students interested in blockchain, specifically Algorand and AlgoBharat, to learn, to collaborate and innovate. From every AlgoBharat ambassadors here, I would like to announce that whether you're beginner or experienced, there's something here for you. Now allow me to introduce the speakers. Ms. Meet Thosar, AlgoBharat Pune Ambassador, Mr. Jason Nilkamal Thoda, AlgoBharat Assam Ambassador. Thank you for being here. Now I'd like to hand over to you people.
Now I'll share my screen and we'll okay. First of all, don't worry. Even if you are new to blockchain, I'll take a baby step to uh, uh, talk about the blockchain. Whenever you are like, do you if you have any queries, you can put the comments. Jesu is there to like if explain the query, or I'll be there also to explain the query. So let me start the presenting now. So can you see my screen? I have started my slideshow. Can you see my screen?
Yes, me.
Okay. So this is me, Thosar. I'm from Pune, Maharashtra. Actually, I'm basically from a very small city, Sangli in Maharashtra. I completed my education there, and past 15 years I'm in Pune as a working professional. Uh, I have started my career in a startup, and then after 4 years I started my freelancing journey. That time I realized that I need to work with the teams as well. So in the 2020 I started my job with one Italian company. I started my career as a core PHP developer. Then I worked with the different CMSs, and then my core competency is in the working with the web to applications from scratch to deployment, like end to end deploy development of the project. So right now I'm a senior software engineer at Adventus, and in 2022 I got introduced with Algorand by through one hackathon. I participated in that hackathon, and I implemented transcript project there and won the second prize there. And after that, I participated one more hackathon by Algorand, that is greenhouse hack, and I got first luckily I got first number, so I went to decipher that year. And on the both end, I could meet the AlgoBharat team, and that from that onwards I started my journey with AlgoBharat. And now from last June, like 2023 June, I'm working as a I'm a AlgoBharat regional ambassador as well in Pune. So I'm a developer as well, and plus I'm trying to help in the developer community in Pune city. So this is my introduction. If you want to connect with me, you can Google my name, Meetho sir, in Google. So you will get all my socials in the Google itself, because of it's a little unique combination of name Meetho sir. So we will get the easily my socials in the Google itself. So no, okay. Now we will start with the basics. We will not directly jump to the Web 3. So we will take the baby steps from Web 1. Okay, what is Web 1? Okay, so Web 1 is nothing but uh, it is read only web, we can say. The innovation started timeline, like innovation started with 1990, and it got developed slowly in next decade. Or in the Web 1, there were email read only websites. The very less user interaction, because this websites very uh, less only read only. So because uh, no user interaction, right now we are uploading and downloading many things through web. That was not easy in the Web 1. And after some time they realized that we need to search few things in the web. So they introduced a search engine there, so we could uh, very early stage search engine was there, so we could search little content over the internet. Web 1 was like a beginning of making internet accessible to everyone. Maybe we can say it as a foundation for the future advancement. Now we are in the Web 2 era and slowly moving to the Web 3 era. So Web 2, we can say it is a refers to the internet's evolution during the early 2000s. So where it became the more interactive and user centered. And now you always already using the Web 2 platforms like WhatsApp, Instagram, Facebook. We are uploading our videos, photos, blogs, and nothing, like we don't have any private life now. We have to put everything on the social media. But Web 2 is not the social media. There are many different applications are there. Like in our company we use the Jira project management tool. So we create our task there, we create epics there, we plan our project there. So nothing but we are creating our works in and saving it in the centralized database, and everybody can access through that centralized database. So we can say that is a single source of truth. So like it is easy for communication, right? Because if I'm updating some data, or updating some ticket, anybody can see who has the access to that ticket. Anybody can see, which was not easy in the Web 1, because it was only read only. The only HTML CSS was there. The only developer could add content and deploy it. But the Web 2, we get nice user experience with the Web 2, and we can easily interact with the internet using Web 2 platforms. So now even though see no any technology is bad, completely bad or completely good. So to evolve, or we see many missing parts in the technology. That's why we start evolving, or that's why we start introducing new technologies to the existing one. So if you are using any product like Facebook or Instagram for free, that means you are the product for that company. Means like they are maintaining such a big company, infrastructure, tech team, so they should have the revenue for their teams as well. So they are selling our personal information to the advertisements. So they are using our addresses, our likings, because we ourselves are putting all the information to the internet, and that's why they are using that our liking, disliking, search history for targeted advertisement. And basically they are using for uh, personal data as their revenue model. Okay, but web 2 transform the internet into the dynamic platform for the collaboration and sharing, significantly impact how interact online and how business operate. But uh, few of people see, so we completed that, like read, write, web, and everything moves online, source of truth, and use personal data. But yes, as I said, there is no technology completely bad or completely great. So there were some missing parts, same as web 1, there were some missing parts in the web 1. We saw some missing parts in web 2. Here we are like, uh, they are using our personal data without our consent. Similarly, in the centralized database, like if you see the circle in that, it is a central authority. See, right now we are using cloud, correct? So the data is distributed but not decentralized. It is a centralized database. One company or one entity has hold on that data, so they can do anything with our data. So everybody is interacting with that this database, and uh, communicating with each other through this centralization. And this is great because of like chatting. I am sending some message to Jesu. It will be saved in some database, and Jesu will read that message from the database. So it is easy to communicate and easy to work with. But in the decentralized database, everybody has access to their data, own data. Like they can communicate with each other, and uh, they, we can say that there is a no single entity who has hold of that data. So right now you just see this image, and after few slides you will understand more about the decentralization. Just right now, uh, from the decentralization we have removed the main one database, and we have moved to the decentralization. Okay, so there were like Bitcoin was created. Like now we are moving to the web 3 part. When web 3 part was introduced, when Bitcoin got introduced, and why Bitcoin was actually created, because it was created to offer decentralized alternative to the traditional fiat currency. Okay, now alert. I will start using different jargons, and I will try to explain those jargons once after one after every slide, so you will not find difficulty to understand the further concepts. Okay, fiat currency. What is fiat currency? Right now we are using rupees, 2000 rupees, 1000 rupees. This is our fiat currency. In US they have the US dollars. US they have the dollar as a fiat currency, and in the blockchain that they have the cryptocurrency. Okay, because it is a crypt uh, um like you just imagine that our India and US, these are two countries, and they have their own currency like rupees and dollar. Similarly, there are two different blockchains, like you can say Bitcoin, Ethereum, and Algorand. Just imagine that these three are different countries, and every country has their own currency. Bitcoin has Bitcoin, Ethereum has ETH, and Algorand has Algo. So Bitcoin was introduced to give the alternative solution for the decentralized solution for the traditional fiat currency. which is not controlled by any bank. It operates transparent in the public ledger, typically incur lower transaction fee. Okay, now there are uh, few more jargons are there, like transparent, public ledger, and the lower transaction fee. We will come after some few slides, so I will explain it in very detail. So right now you just listen to these jargons. I will explain it very uh, subtle way, so it will be easier for you to understand. So first, I will give you one my personal example. In 2022, when I participated in one hackathon, there I meet two friends who were working in the blockchain. One is from Ghana, one is from US. We created our team and we participated in one cohort. So we created one project there, like presentation there. We presented in front of panel, then we got selected for the further steps. So that time one of the friend from that Ghana met with accident, and he immediately needed a money, and few tests, and he was a lack of money, so he asked us to send the money. How could we? But we had one common solution with in our hand: blockchain and Algorand. We all of three had a Pera wallet with us. We had uh, algos in our wallet, so we send 100 algos. The US friend send him 100 algos. He took those 100 because it is just wallet to wallet transfer, right? There is no permission required. So I sent the 100 algos to there. He converted that algos to the uh, his fiat currency, whatever the currency is in Ghana, and paid his bill for the hospitals. That time I realized, okay, this is the main goal of the blockchain. So we can say it is a permissionless. Otherwise, if I wanted to go with the uh, traditional way, I had to inform my uh, bank. Then it will connect to the Ghana bank. Then I have to send that money to different. It will the money will hop from one bank to another bank, and then he will receive the money. Maybe it will take 3 to 4 days, and by that time, how he'll pay for his medical bills, correct? And but due to Algorand, I could send him 100 algos in just few seconds, and uh, he could pay his bill. And that time I realized the importance of the blockchain. That time I was just checking it as a only technology, but the real use case was here. So now, uh, what is blockchain? Okay, the though it is a Bitcoin, everybody there is one myth. Biggest myth for the blockchain is that the blockchain is the cryptocurrency. No, as I said, in the Bitcoin, Ethereum, Algorand are the blockchain, but cryptocurrency is their currency of that country. Like blockchain is the country, and the currency is like tokens are their currencies. So blockchain is not cryptocurrency. The underlying technology of this cryptocurrency is the blockchain. So now I will give you one more example for the blockchain. Okay, just imagine you are seeing one railway. Okay, in the railway, just imagine every bogie is the block, and every bogie is connected with the chain. So that is the blockchain. And in every bogie, there are passengers sitting in that bogie. Every passenger has purchased the ticket for their uh, journey. And nothing but these tickets are nothing but the transactions, because there is a give and take. The people are giving the money to the ticket like railway station, and getting the ticket. This is the transaction, correct? And every passenger is the transaction in that block. So the whenever you imagine the block, you can imagine it as a train. and bogies are the block, and these blocks are connected with the chain, that is the blockchain. Yeah, it is a very simple example, but in real life blocks is the blockchain is quite a difficult concept. We will unfold it slowly. Okay, so what is block? Right now we just imagine that block is a bogey, but now in the real blockchain, what is block? It is a uh, uh, okay, so right now let's say take a one rectangle block. Okay, so I'll add that number to that block. Okay, right now it is only zeroth block in our blockchain. Okay, so let's take one nouns I'll explain it in the later slide. Right now just consider it is a number which is very significance in the block. Okay, right now I'm explaining very general definition of block. It is not applicable to any exact blockchain. Okay, I'm explaining the general structure of block. Okay, then it is a data. What is data in the block? All the transactions. Okay, I'm sending some money to Jesu, like say 100 rupees, and then Jesus gave me some product from his business. So that is the transaction. So right now one more jargon will be introduced now. Now asset is one jargon you will hear me speaking many times now. Now just imagine that whatever we are doing, that whenever I'm telling you the transaction, there is some exchanges between the money or the asset. If you are buying some property, that is the asset. uh, what like you are like we are swapping, like you are farmer, and there are two farmers, then they decided to get one have the rice with him, and one have the wheat with him. So he decided to swap that. Okay, he said, okay, I'll give you 10 kgs of rice, and he said that, okay, I'll give the 15 kgs of wheat when you give me 10 kgs of rice. That is the assets. Okay, the farmer has the rice as an asset, and the another farmer has the wheat as asset. They are swapping those assets. These are nothing but the transactions. So we will keep all these transaction as a data in the block. Okay, that data is not in the plain text, like you cannot read it like any text from the book or in the like a blog. It is encrypted data. And timestamp, when this transaction is happened, we will note down that time in the block. Okay, right now what is the time? It is a 11:41. So right now if this block is getting added to the blockchain, that timestamp, or when the transaction is actually happened, that timestamp will be added to this block. Okay, so now next is the previous block. Ph, what is ph? Previous hash. And what is hash? It is a hash is the 64-bit characters, sorry, 64 characters hash number. Okay, now what is hash? Now one more uh, difficult word is there. So now just imagine, right now just imagine hash is a function. Okay, we are giving some input data to that hash function, and it gives me it will process that data under that function, and it will give me 64 character hash value. Okay, it will give me 64 characters. And uh, even if there is a huge data like 2 mega, not huge, like if there is a pdf, it will give me 64-bit characters, 64 characters string. Even if I'm sending just meet toaster to the hash function, it will give me 64 character string. But if right now I'm writing my name as a meet toaster in a small letters, okay, and I'm giving to that, giving this name as an input to that hash function, it will give me some hash value to as an output for that function. But if I change my case for that name, like M is a capital, other letters are in a small case, then the hash will change. So even if there is a small change in the file, the hash will change. So it is a unique value for any of the data. So when the new block is added to any blockchain, this like this block number, nouns, data, timestamp will be clubbed together, and it will be hashed and kept as a hash. It is a identifier of that unique identifier of that block. Like everybody has their thumbprints in the Aadhaar card, right? Because it's a unique for everyone, and it will remain like from it will not change anytime. So it is our, like our thumb is our unique identifier. Similarly, the hash is the unique for every block. And now, uh, uh, before moving to the next part, I will explain few types like which are required for the further discussion. Okay, so what is the transaction? Right now I just uh, told you about the transaction. It is there will be sender, receiver, and amount. The amount can be in the algos or the asset transfer. Like I'll create one asset in the Algorand blockchain, and I will transfer as a sender, I will transfer to the receiver. Then the asset, I just explained that asset. Just imagine that the whole world is different, have different assets. Okay, then you will start imagining the transaction more easily. I'm transferring one asset to one receiver, and I'm the sender. That's it. Right now I'm telling you about the blockchain. I'm transferring or transferring my thoughts to you. That is also transaction. And my knowledge is the asset for me right now. Okay, so the smart contract and account. What is account? So right now almost everybody is using UPI. Okay, everybody must have the account in their bank, and every blockchain will also have the account, account in the blockchain. So and it will have the public key, private key. Now just imagine you are sending email. Okay, email ID is your public key, and private key, what is the private key? Password of that email ID is nothing but the private key. In the blockchain as well, there is a account wallet address, and wallet address is nothing but the public key and private key, which has to be kept very secure, and it will be used to to create the transaction. Okay, now you people may have written the check in the bank, right? If you are transferring some amount from one bank to another bank, or one, like you are sending some money to your friend, that time you will write the amount, you will write the account name for that receiver, and you will sign that check. Correct. Similarly, in the blockchain as well, you have to sign that transaction. We will call it as a digital signature. And once you sign that transaction, then only the transaction uh, will go to the blockchain for the validation, and the block will be added. So the private key of the account and the public key of the account is very important, and it plays a very vital role in the blockchain. Okay, and the smart contract. What is smart contract? um, right now I'm sending some money. Right now I'm using UPI, correct? So sending, I'm getting the Jesus number and sending him 100 rupees. That time, let's say I have Axis Bank account, and he has the HDFC account. So my bank will deduct money from my Axis Bank account and will transfer money to the HDFC Bank, and then he will receive the money. But in the blockchain, you can directly transfer to the uh, receiver's account. And but there is a no intermediary, but we will use the smart contract. Smart and contract is nothing but the agreement on agreement on some terms, like sender is setting some terms, and receiver or who is doing the transaction between two people who are doing the transaction are in the common agreement. And will be there will be different validations that um validations which need to be completed before sending the transactions. What can I give you example? Okay, if you are purchasing some property, okay, like you will not send any money to builder before any agreement, correct? You will sign that agreement, and then the money transaction will happen. Similarly, there is some procedure, like you have to give your identification, you have to give your Aadhaar card, you have to give your ITR file or some salary slips and all these things. These all the validation. Similarly, there will be validation, different validations will be there, because there is no intermediary, there is no manual intervention, there is no person to uh, to check that transaction there. So we have to write the smart contract for that. In Algorand we call it as application, and through using that smart contract we can do the transaction. And it is uh, smartly auto executable program, you can say. It is a smart contract. Okay, so now these terms will be used again and again. So I explained it in the first uh, uh, before starting the more deep in the like blockchain terminology. So now in the previous slide, um we discussed about the block number, nouns, data, timestamp, previous hash, and the hash value of that block. What is previous hash? Like right now, let's say this is the first block of the blockchain. We call it as a genesis block. So this is the first block. That's why it's a 000, because it does not have any previous block. But when we started new transactions, then we will keep let's say one more transaction is happened on the blockchain. So the transaction data and the block number is created, and this previous hash value is will become the previous hash of the next block. The previous hash value, the hash value of the first block will become the previous hash value of the second block. And and that's why we call it as a chained blocks. That is it, that's why it is a blockchain. Block is chained with these values. But now let's say, uh, uh, if someone has attacked the blockchain and tries to change the number block number 1, what will happen? The hash value will change, correct? Because as I said, even if I change my case of the name, like meet toaster and mcap, if I change my name from small meat to capital meat, the value will change, correct? So if I try to change any of the value from this block, like let's say I change some data, transaction data from this block, the hash value will change, because we club all the information from the block and create the hash of the value. Okay, so this hash value and the previous hash value of the next block will mismatch, and this the hash value of first block and the previous hash value of the second block will also mismatch. And that's why the attack will be recognized, and the algorithm will take the correct action on the blockchain and the attack this. That's why we call the blockchain is very secure, because they are linked with the hash values. Okay. Hope, Jesu, am I speaking very fast or is it fine? Hello. Okay. So, uh, So slide now this is the we discussed about this blockchain. Okay, now this is the data. We have chained blocks in our system. Now this blockchain is copied into different nodes. What is nodes? Nothing. Node is nothing but the computer who is running the Algorand blockchain or any blockchain. So these big rectangles are nothing represents the nodes or the computers who has the copy of the blockchain. So every node communicates with each other. We call it as a peer to peer. And let's say one node is being attacked by the hacker, and but every time every node is communicating with each other and validating their blockchain records. So that's why they can validate whether the blocks are properly kept, like blockchain is properly kept. If there is is there any mismatch in the data, every data is sync or not. And if they find any ambiguity or any problem with the data blockchain, they will get the latest blockchain updates from the all the data. They will check which is the correct blockchain, and it will replace the hacked, or it will just remove that node from the blockchain. There will be different cases with it. So this is decentralization, because everybody has their copy of the blockchain, so nobody can attack on the single computer and change the blockchain. You have to be sync with the every every node, and then it will become secure as well, and the transparent as well. Okay, so the in the simple terms, a blockchain is a public ledger. It is a sequence of transaction organized in blocks, guaranteeing three fundamental properties. Everybody can read every block, so the blocks become common knowledge, and everybody can write transaction in a future block. No one can alter the transaction in the block or the order of the block, as we discussed in previous slide. Now there are only 3 points, but I will explain it in more like in a single words. Like everybody can read the data means it is a public blockchain, right? Everybody means you can say it is a transparent. Everybody can write the transaction in a future block. So you can call it as a democratized, or like if you want to, like anybody can create their account in the uh, uh, with blockchain like wallet. Say, like in the Algorand we have the Pera wallet, so you can create your account and can start the transaction. So it is a democratized, like borderless, or anybody can join the blockchain and start working with the people, and no one can alter the transaction. The blockchain's main purpose is that it is immutable, irreversible. Once the block is written to the blockchain, you cannot edit the data. That's why we call it as a immutable, or you cannot alter the transaction. So that's why it is a very secure. Though it is a public blockchain, though you can read any information, but due to encryption, the data is not kept in the plain text. It is securely kept with the encrypted or cipher text. Okay, now let's go to previous slides. Okay, these are the four, let's say there are right now there are four nodes, but in blockchain there can be thousands of nodes who are working together as a participant of those blockchain. But there must be some agreement to add the block, correct? um, Okay, let's take one example. Now you are 5 to 6 friends are there, sitting in the college and deciding to go to movie. Okay, so you will discuss, no no no, we will नहीं हम OTT पे ही देख लेते हैं, We will no we will watch some serious movie, we will see some horror movie, we will see some comedy movie. There will be discussions around movies in your group. But to go to any movie, you have to be some in a common agreement. Correct, you have to decide whether uh, which movie to watch, or do we want to go to any theater to watch. There must be some agreement in your friends, then only you can plan it, and then you can watch the movie. And in the blockchain, there should be some algorithm, or there should be some method to communicate with each other and come to agreement at one point, where whenever they want they want to add one more block to the blockchain. Okay, before adding any block to blockchain, every node from the blockchain has had should have the agreement, or not every, at least two-third of the blockchain, more than two-third should be in the agreement that okay, this block can be added in our blockchain. So we call it as a consensus. That is, there should be some common agreement between the nodes, where when there will be new block is going to be added in the blockchain. So we can call consensus refers to the way blocks are selected and returned to the blockchain. Now there are multiple types of consensus mechanism. We call it as a mechanism because this is our method which will be used to add new blocks. So we will discuss only main two consensus mechanism, that is proof of work and proof of stake. Okay, what is proof of work? um, okay, before moving to the any consensus mechanism, or any technical deep dive into this concept, I will tell you one story. Okay, I will read one. Okay, let's say there are two villages once upon a time. Like whenever we talk about any story, we first sentence comes in our mind, that is once upon a time. Okay, once upon a time there were two villages. Okay, in the one village name was Rampur, and another village name was Ratanpur. Okay, in Rampur, everybody was fueled with the spirit of competition. हमेशा वहाँ बहुत उत्साह रहता था कि चलो काम करते हैं, ये करते हैं, वो करते हैं. And decision for progress was hard fought. Like everybody, every time there was बहुत झगड़ा होता था कि नहीं, मैं करूँगा, मुझे क्रेडिट मिलना चाहिए. Like whenever new idea emerged, a clash of opinion ensued, often resulting in the emerging of two winners. And then these winners frequently set out separate paths. Like one will say that okay, I'll create the roads from south to north, and one will say no, no, I will create the roads on different way. But winners frequently set out the separate goals, and each implementing their own ideas. However, as time passed, many half-cooked ideas were implemented because funds कम पड़ जाते भाई. एक रोड अच्छे से बनाते तो वो लंबा रोड बन जाता, but when the people are trying to create two roads in the same funds, one is going to stop because of the whatever whatever the reasons, वो funds कम पड़ जाते हैं कुछ भी, and which were not useful for the people. Correct. It became evident that this path was inefficient and time consuming. On the other hand, in the village of Ratanpur, old and wise man used to propose an idea in front of villagers, and with the richness of his idea, he used to propose wonderful ideas and decides few new things for the village. The other committee of old and wise men used to think about his idea, and if they all agree, the idea is implemented, and villagers start using this facility in no time. Okay, now Now imagine Rampur is nothing but the proof of work, and Ratanpur is nothing but the proof of stake. Now, slowly, I will match these terms with the technical terms. Okay, right now we will start with the proof of work, where the nodes are fighting hard for their new block proposals. Okay, now just imagine there is a pool of numbers. Okay, hexadecimal numbers start with the 0 and end with the FFFF. There is a pool of hexadecimal number. Okay, right now I will tell you the comparison between the Bitcoin and the Algorand, because right now Bitcoin is using proof of work and Algorand is on the pure proof of stake. In the June 2022, Ethereum was using proof of work, but now it is also on the proof of stake. But there is also difference between their proof of stake and the Algorand proof of stake. Okay, first I will explain the proof of work. Every node is participating in the consensus. Everyone will get one puzzle to solve, and whoever the solves that puzzle first will propose a block. Okay, or who that though that node will add the block, or that account will add the block. So the algorithm or blockchain algorithm is has given them one puzzle. What is the puzzle? That is, they have to find one number or hash value, like this is the hash value. Okay, the puzzle is around that hash value. The puzzle is like find the hash value where that hash value ends with the four zeros. Okay, then they will use the brute force method. Okay, every node will start working on that. They called it as a miner. Okay, they will start with the one. They will get all the information of the block number, data, timestamp, and previous hash, club together, add one, and uh, add that as an input to the hash function, get the hash value. Is it matching? Does it end with the four zeros? No. Then again it will take another number 2, again run the hash function on this bundle of the data, uh, check the hash value, it is ending with the uh, four zeros. No. Again 2, 3, 4, and maybe that there is a one number like 20. That time that node gets the exact number, like exact hash, that block number or bundle of the data, nouns, and provided to the hash function, and it got the hash value which is ending with the four zeros. Okay, then he will announce that okay, I have solved the puzzle, and he broadcasts that message to the all nodes. But he will add the node because he is the winner. He solved the puzzle. He will add the block to the blockchain. But what is fork? Then there, like similar like Rampur, right? Not Ramnagar. Rampur. There can be one more participant who who solved the puzzle, and he broadcasted the message again. Okay, I have solved the puzzle. This is my block. Add to the blockchain. Okay, there is a thousands of nodes are there. His broadcast message is propagated to few nodes. They added that block to their blockchain and they started their own chain. Okay. Similarly, one node also found the puzzle answer. He broadcasted that message to his network, and that they will add they will add that block to the blockchain, and will continue to adding block. Okay, then similarly, just imagine that this is the path is nothing but the blockchain. Okay, and there is another block, there is another path where the blockchain is working. Okay, so that is the fork though. So there are two ways are going in the blockchain. It is not valid because every node like every computer from the blockchain should have the same copy of blockchain. Then the algorithm will run and will find the longest chain, the who which nodes have the longest chain, and what number of nodes have the longest chain, and the smaller chain will be invalidated. All transaction, all data, all transaction will be invalidated from that another forked blockchain chain, and the longest chain will continue to add new blocks, and that is fork. So uh, there so there can be like you have completed one transaction like sending money to your friend, but if that block is on the that forked blockchain, then that transaction will be removed from that blockchain. And that is why uh, like in the blockchain, the finality, like completing the transaction and writing to the blockchain takes time. In the like maybe block proposal may get in the 10 to 16 minute uh, in the bitcoin, but finalizing that transaction to the blockchain will take 1 hour. Okay, because they have to run this, they have first of all they have to run the puzzle, they have to fight for the like fight has to fight the competition, have to win that competition, and then propose a block. And after some time the algorithm will run to check whether there is any fork in that chain. If there is a fork, then invalidate that smaller chain and continue with the longer chain. And that's why, as we said with the rampur, there is a half cooked chains was there, so it will be removed. So transaction and the time is gone for those participants who were the participated in that transactions. Correct. So the two winner, two four, and it became evident that the path was not efficient and the time consuming. Now uh, just imagine, let me have some water. Now just imagine you are in the coffee shop, you have bitcoins with you, and you want to pay the coffee cafe with the bitcoin. You send the bitcoin to that cafe and waited for 1 hour to get finalized. Finality means the transaction is added to the block and block is added to the blockchain, and it is completed. That is finality of any blockchain. And you have to wait for 1 hour, and then he will receive the bitcoin, and then only he will start making coffee for you. And if your transaction is in the fourth blockchain, then your transaction is invalidated. Then again you have to wait 1 more hour for sending the bitcoin to that cafe and get the coffee. So it is not feasible to create the actual real application in such scenarios. Ethereum was also on the like proof of were using was using proof of work. Now it is also switched to the proof of stake, but still it is a finality. Like adding block is almost takes like finality takes almost 10 minutes. So but now we will uncover for the Algorand how it works. Okay, so now okay, now we will start with the, now I'll give the history of the blockchain or how it basically works in the blockchain. Now we will start talking about the Algorand, how it is working. Okay, the MIT's officer Silvio Macaulay, who introduced Algorand, he is a founder of Algorand. He is the one of the forefather of modern cryptography and Turing Award winner. Now, Turing Award is nothing but the Nobel Prize in the computer engineering. So, the co-inventor of this probabilistic encryption or the ZK knowledge proof is the same, like uh, maybe it's quite difficult, but I'll explain it in very simple way. Like probabilistic encryption. Like right now, we saw that block, right? The data is kept, data for that transaction is kept in the block. We won't be, though it's a public ledger, nobody, anybody can see that transaction, but anybody should not read that. The only authorized who has the access to that transaction, or who are the participant or the transaction, should see that transaction. So that data is not kept in a plain text in the blockchain. We have to encrypt it, and it is a probabilistic encryption is applied for that transaction, and then that data is kept in the blockchain. So if I want to explain the encryption in very simple way, then you imagine that is a, whenever we go out from the home, we lock the home, right, with the lock and the key. So whenever we come back, we use same key every time we to unlock that lock, right? But in the probabilistic, so every time you will get the, uh, every key, every time every one key will be used. But in the probabilistic encryption, there is a special way of locking the information is using cryptography. Unlike regular locks where same key always gives same result. Like एक बार ताला खोलने के बाद आप घर ही जाते हो, कोई दूसरे के घर में अंदर नहीं घुस सकते. But in the probabilistic information, like there is some data. Let's imagine there is some data or very confidential information, but you used one key to encrypt that. But whenever you change, probabilistic encryption adds the bit randomness in that. This means even if you use the same key to log the same message many times, you will get the different result each time. So it is difficult to guess the information. So this randomness makes it much harder for someone who is trying to break the lock to predict what's inside. Correct. It gives the very uh, great security for that data. Now what is zero knowledge proof? So we will not, it actually this is out of syllabus for this session, but I will give you very uh, small example for these uh, concepts. Okay, what is zero knowledge proof? Mm, like zero knowledge proof is like, uh, you want to prove something, but you don't want to give any exact information about yourself. Like okay, tell me, you are an adult, without telling me your actual age or birth certificate or any Aadhaar card. So that time you can say that okay, I can vote. Okay, I can vote is the public information. Okay, so you are not telling me your birth date, or you are not revealing any personal information. So still I can understand, okay, you are above 18, means you are adult. It's a way to convince other you have piece of information, and without sharing the information itself. This is super useful for online security and privacy, because you can prove you are the authorized without giving away your secrets. Now the some like in we say the Bitcoin is also decentralized. It's very secure. But if one transaction is taking 1 hour, then it is not possible to create the real life applications with the Bitcoin, because it's not scalable. It is not easy to transact in the Bitcoin. So but in the Algorand, we can complete it in very few seconds. That's why uh, the Algorand solved this trilemma, that is decentralization, security, and scalability. Now I'll explain the verifiable random function in next slide. So we discussed the proof of work in the previous slide. Now we will discuss the pure proof of stake in the next slide. In the Algorand. Algorand is the new blockchain which use the consensus mechanism as a pure proof of stake. What is stake? like every account, like similarly, like we have bank account in the Algorand, we have the accounts or the wallets who has funds in that, like algos in that, and we stake that. And who, like in the pure proof of stake, in the there will be no puzzles. Okay. There will be no puzzles, no forking will be there. So, because a verifiable random function, in Algorand there is one function, we can call it as a lottery. Okay. uh, that function is used to create the consensus. Okay. Lottery like system, leader proposes a block and committee votes. Now just remember the previous story, Ratanpur. Okay, there was a Ratanpur, and there was a wise man with his knowledge of richness, richness of his knowledge. Okay, so right now in blockchain, who has the good stake in their account, who is taking good amount of algos, there will be multiple accounts. Okay. And with the random verifiable function is the um, okay with okay, now I will explain it with this diagram. Okay. uh, Now just imagine, I'm the node. Okay. So I have all the account list फ्रॉम द ब्लॉकचेन. जैसे हमारे बैंक में अकाउंट लिस्ट होती है, डिफरेंट अकाउंट है, डिफरेंट पीपल हैज देयर अकाउंट्स. Similarly, the every node will run this proof of stake, like, sorry, verifiable random function through their accounts. Okay. uh, like uh, there are like these green boxes are nothing but the accounts, and with the random verifiable function is the हमारे यहाँ में टॉस करते हैं ना, जैसे like we toss the coin, like a coin flipper. It will be used as a coin flipper in the for the computer. It's a tool generates a random number, and with that random number, each the account will be selected to propose a block. Let's say this orange account has been selected, and it will propose a block. Every node, like every computer from the blockchain, is doing same. They will propose a uh, they will propose a block, and with same function, random verifiable function, one committee of account will be selected to verify that block. Okay. It is coming from the correct account, it is not a malicious account. There will be different validations for that, and everyone will vote for that block. Okay. So these are orange, you can see the orange ticks. Okay. These orange ticks are nothing but the blocks. Once this soft voting is completed, another committee will be formed with the verifiable random function. They will also vote for that block. Okay. And um, that block will be added to the blockchain, and this whole process is completed is will be completed less than 4 seconds. Okay. Now just imagine, there is the 1 hour and the less than 4 seconds. Now let's consider same scenario in the coffee shop. You're in the coffee shop, you have Algorand Pera wallet with you. You want to pay in algos. You pay algos for the coffee. Within 4 seconds or less than 4 seconds, the transaction is finalized. It is completed, and they will get the algos in their wallet. And just next 10 minutes, you will have the hot coffee with in front of you. So now you can imagine that we can create the real life applications in the Algorand. Okay. Do we need to create each and every component of the application in the on the blockchain? No. See, as I said in the first place or on the first slide, we don't have to scrap all the technology. We are evolving. So right now Web 2 will remain as it is. We are adding new security layer or a new flavor to the Web 2 applications. So let's say there is some application where there is a trust factor, or there's some immute there's should be some data which need to be immutable. Then that only component can be created using blockchain, and other application can run as it is as the Web 2 platform. So we can say that it is a Web 2.5. The Web 2 platform is already running smoothly, and we are adding one security or the trust layer for that Web 2 application, and it will become the blockchain application. Okay, so we can call it as a Web 2 application. So now, if you have heard about the carbon footprints or carbon negative, like carbon footprints or carbon credits, like just imagine every computer is competing to solve the puzzle in Bitcoin. Okay, so everybody has to have good computers with strong ability to run the puzzle faster and get the results. So they must have the energy, very energy consuming. So energy consuming, and the if there is energy, there will be carbon footprint. But in Algorand, we are completing our transaction in less than 4 seconds, and due to that proof of stake, uh, whoever the has whoever has the good stake in their account has the most more probability that the account will be selected to propose a block. It will, and it is happening very randomly, right? So no one can guess which account will be used to propose a block. So there is a difficulty to guess the account as a block proposal, and it's all things happening less than 4 seconds. That's why we can call it as a carbon negative. So we are not we are consuming very less energy, and that's why we are not keeping any carbon footprint in our environment. So that's the last slide for the presentation. Before moving to the next part, I want to take some feedback from you guys, how things are going, whether it's very difficult, or do we need to stop for some queries, and then I'll show some development in the AlgoKit and Algo thing. So Neha, Jesu, is there any questions from the students? Okay. Uh, I guess there is no questions, so I'll move to the AlgoKit. Okay. So if you want to if you want to repeat some part for from the previous slides, let me know. I will try to give some simpler example. Maybe I was little faster. If it is so, let me know. I will try to explain it more in a simpler way.